Okay, guys. Today we are going to be talking about operation with radical expressions. It's pretty simple. Very similar to when we were adding like terms and all that good stuff, because you have to have the same variable to the same power. Very similar. Today we're going to be dealing with like radicals. And like radicals are radical expressions that have the same index. Remember what we're talking about with index. Index is the little number right here. That's the index, okay? If it's invisible, the index is 2. Very good. So, like radicals are radical expressions that have the same index and radicand. Remember that the radicand is the inside value right there. If the radicand and the index are the same, you can add or subtract them. Only like radicals can be added or subtracted. Only. Unlike radicals, such as 4 radical 3 and negative 2 radical 2, cannot be added, cannot be added or subtracted. So let's talk about this. Let's see what I'm talking about. 3 square root of 5 minus 2 square roots of 5x. Do they have the same index? Do they have the same radicand? So what is 3 square roots of 5x minus 2 square roots of 5x? 1 square root of 5x. Done. Here, I have 6x squared square root of 7 plus 4x square root of 5. Do they have the same radicand and index? No. So I'm going to put NP for not possible. C, 12 cube root of 7xy minus 8 fifth roots of 7xy. I can add these, right? They have the same radicand, right? No, because they don't have the same index. Very good. NP, not possible. Not possible. Now, number D, letter D. 17 fifth root of 3x squared minus 15 fifth root of 3x squared. Yes, they are like radicals. So, what's my answer here? 2 fifth root of 3x squared. Please notice, are we adding the insides of the radicand? No, no, no. You treat those like variables, right? If I had 3x plus 4x, it's just 7x, right? It's not 7x squared, right? Right, that's when we multiply that we add the exponents. Okay. 5 square roots of 7 plus 8 square roots of 7. Absolutely right. 13 square roots of 7. Done. 1 square root of 11 minus 5 square roots of 11. Negative 4 square roots of 11. Absolutely right. And have you seen the way I've been phrasing it? I phrase it so that you know I have 1 square root of 11 minus 5 square roots of 11. Because basically what this 5 square root of 11 means that there's a square root of 11 plus a square root of an 11 plus a square root of 11 plus a square root of 11, I'm not being annoying, plus a square root of 11. That's 5 square roots of 11. That's why you're able to add 1 more square root of 11, for example, that'd be 6 square roots of 11. So when you're adding square roots, okay, as long as they have the same radicand and the same index, you're really just dealing with the coefficients. And the coefficients are the number being multiplied in front of that radical. Does that make sense so far? Awesome. Okay. When adding or subtracting radicals, though, sometimes you have to simplify each given radical, if possible, before adding or subtracting. So sometimes you're going to look at something, you're going to say, wait, whoa, I don't like this. This isn't, no, you can't add these, Mr. Morrow. Yes, you can. Maybe. Let's see if you can. This breaks up into 4 times 3. Square root of 4 is 2. So I got 2 square root of 3. You with me? Okay, plus 75 breaks up into 25 times 3. Okay, what's square root of 25? 5 square root of 3. Oh, I can add them, can't I? And then minus 1 square root of 3. So I have 2 square roots of 3 plus 5 square roots of 3 minus 1 square root of 3 will equal 6 square roots of 3. Very good. Now, remember how I told you that the index tells you How many sets to pull out? How many do I need in this cube root to pull out one value? You need 3. So let's check this out, guys. This is 25 times 10, 5 times 2, and 5 times 5. You with me? A 5, and a 5 comes out as a 5. And I have a cube root of 2 left over. Did everyone just see that? Did everyone see that? Awesome. Plus, let's do the 54. 54 is, okay, 9 times 6, I can work with that. That's 3 and 2. Great job. No, great job. I like the enthusiasm. 3 and 3. Excellent, dude. I got a 3, and a 3 that comes out as a 3, and I got a cube root of 2 left over. Does everyone see that? Because I know you do. Good job. Talk to me, boys. Yes, sir. What 3? Because it's a cube root. I got to put the cube root. I got to put the index. I got to leave that index always. Because look, bro, if I go like this, is it a cube root anymore? Now it's a square root, right, my man? Thank you, sir. And then minus, okay, great. Great job. People are on this. This is great. This is 2 and 8, or you could have done 4 and 4. It does not matter either way. 4 times 2, and then 2 times 2. So remember, guys, we're looking for sets of 3 this time. So a 2, and a 2 comes out as a 2 with a cube root of 2. So what's 5 cube roots of 2 plus 2 cube roots of 3 cube roots of 2 minus 2 cube roots of 2? It's going to be 6 cube roots of 2. Heck yeah. Awesome. Awesome. You are killing this. I'm so proud of you. 14 times, okay, well, actually, why did I do that? Well, actually, yeah, because I have a 14 on the outside. Okay. This 4 times 5 was square root of 4. So multiply by 2, I have a radical 5 left over. So I got 28 square root of 5. You feel me? Who said no? So I can help you. Oh, okay. So then this is 5 and 25. What's the square root of 25? 5. Bam. Take out a 5. What's left over? 5. So what's 28 square roots of 5 minus 5 square roots of 5? 23 square roots of 5. Oh, yeah. And this one, guys, how many are we looking for to pull one out? 4. Very good, guys. Very good. So this is going to break up into 2 times 16. 4 times 4. 2 times 2. And 2 times 2. 1, 2, 3, 4 2's comes out as a 2 with a 4th root of 2. Excellent. 48. That's 3 times 16, which is 4 times 4, which is 2 and 2, and then a 2 and a 2. 1, 2, 3, 4 2's comes out as a 2 with a 4th root of 3 left over. Oh, can I add these? Oh, man, I know it's tempting. If I gave you this as a question, this is how you would leave it. Nice and beautifully simplified, but I cannot go any further. Yes, sir, Papo. At this, if I give it to you like this, my man, if you just gave me that, you don't have to put not possible. If you just put that and you circle that, that lets me know, okay, my boy knew how to simplify this, and then he reckoned, or she out there in the internet world, he or she recognized, hey, wait a second, I don't have the same radicand, I cannot add those. Okay, my man? Thank you, sir. If I gave it to you in a format like this to begin with, then you would go, not possible. Does that make sense? Does that help? Thank you, gentlemen. Okay, next. Remember that you can multiply the radicands of like index radicals. However, you can never multiply rational numbers with radicands. Guys, square root of 2 times square root of 5 will equal square root of 10 because they have the same index. But a lot of you guys are making the following mistake. Square root of 2 times 5, you're still putting it in square root of 10, and that is wrong. Square root of 2 times 5 is simply going to be 5 times the square root of 2. You cannot multiply integer values or real numbers with radicands. You feel me? All right. Yes, go ahead. Someone said so? Yes, sir. No, not impossible. If I have square root of 3 times 7, that's going to equal 7 square root of 3. But it will not equal square root of 21. No way. That is wrong. Thank you, sir. Here, this is just polynomial multiplication like normal. If you learn how to do it before using the FOIL method, you're fine. If not, it's going to be tough. And yes, distribute. 4 times 5, you got 20 plus 16 square root of 2. See how I did not multiply that 4 to the inside? I multiplied it to the coefficient. Then I have 2 square root of 2 times 5 is plus 10 square root of 2. And then 2 square root of 2 times 4. I love this one. Look. Wait, hold on. 2 square root of 2. Let me show you what happens here. Times 4 square root of 2. You guys got to start doing stuff in your head a little bit. What's 2 times 4? 8. But what's square root of 2 times square root of 2? So what's 8 times 2? That would be 16, guys. Remember, whenever you multiply the same radical, it equals itself. Remember, we did that, guys? So then at the end, this is going to be 20 plus 16 is 36 plus 26 square root of 2. Guys, 16 plus 20 is 36. 16 square roots of 2 plus 10 square roots of 2 is 26 square roots of 2. Okay? Now, 3 times 5 is 15. Then you have plus square root of 21, right? See, for all of you that said, yeah, you're not listening to me today, that's a big fat no. 3 times square root of 7 is simply 3 square root of 7. You cannot multiply real numbers with radicands. You cannot. I'm sorry, you can't. Now, negative square root of 7 times 5 is negative 5 square root of 7. And negative 7 times square root of 7 is negative 7, guys. Okay, let's do it again. When you multiply the same square roots, the answer is simply the radicand. Negative square root of 7 times square root of 7 is going to be 7. Now I have 15 minus 2 square root of 7 minus 7. So that's going to be 8 minus 2 square root of 7. Done. Okay? I'm running out of time here. So I'm going to skip C. What happens if you square it? What does that mean when I square a polynomial? Tell me the setup. It'd be... No. It'd be 2 square root of 5 plus 3 square root of 2 times 2 square root of 5 plus 3 square root of 2. You have to remember that this square means I am squaring the binomial. I'm multiplying the binomial times itself. Yes, sir. Okay. Now, 2 square root of 5 times 2 square root of 5 is going to be, what's 2 times 2? 4. And what's square root of 5 to square root of 5? 5. So 2 times 5 is 10. 2 square root of 5 times 3 square root of 2 would be 6 square root of 10. Didn't we just finish saying that you can multiply the inside radicands if the index is the same? Then I have 3 square root of 2 times 2 square root of 5, which would be 6 square root of 10. Yes, 2 times 5 is 10. And then 3 square root of 2 times 3 square root of 2? No. 3 times 3 is 9. Square root of 2 times square root of 2 is 2. 2 times 9 is 18. So this will be 28 plus 6 square root of 10. Ah, what's wrong with me? What's wrong with me? Plus 12 square. Someone's saying 30? Really? 6 plus 6 is 12, guys. Okay. Now, if I want to just multiply one square root to a binomial or trinomial, distribute. Okay, guys, so square root of 3 times square root of 6 is square root of 18. Plus square root of 3 times 4. Okay, now we're not done, though. I can simplify this. This comes out to be 9 times 2. What's the square root of 9? So this is really going to be 3 square root of 2 plus 4 square root of 3. Can I add those together? But I really want to. But I can't. Very good. Awesome. It's a rule. Good job. Now, square root of 12 times square root of 4 is? Minus square root of 12 times 5? 5 square root of 12. Whoever said 60, think. I just finished saying at least 5 times already, you cannot multiply real numbers with radicands. Why? Because that's the rule. I can break down 48 though. Okay. I would actually make it easier and go 16 times 3. What's the square root of 16? 4 square root of 3 minus, what is this here? 12 breaks up into 4 times 3. What's the square root of 4? What's 2 times 5? 10 square root of 3. So what's my answer here? 4 square roots of 3 minus 10 square roots of 3 is negative 6 square roots of 3. Excellent. Excellent. You with me, guys? All right. Now, conjugates. Conjugates are expressions like a plus b and a minus b. They only differ in the sign of the second terms. This is exactly the same as that. This second term will be exactly the same as that. The only difference is one is plus, one is minus. That is what a conjugate is. When a and b are rational numbers, the product of two radical conjugates is going to be a rational number. So let me show you some examples of what conjugates are. 1 minus the square root of 5 and 1 plus the square root of 5, those are conjugates. Square root of 3 plus square root of 2 and square root of 3 minus square root of 2, those are conjugates. Okay? Does that make sense? Now let's see how to work with this. See what happens when you multiply conjugates and when you rationalize using conjugates. Now, I don't know why this came out. I was supposed to say hint there, but whatever. Hint. Remember the product of a difference of squares. When you're multiplying conjugates, guys, you're basically multiplying a difference of squares. And a difference of squares states that if you have a squared minus b squared, when you go ahead and factor that out, it's going to be a plus b times a minus b. So, think about this. Isn't this the same a? And isn't this the same b? So it's basically going to be the first term squared minus the second term squared. What's the square root of 7 squared? 7, which would equal 18. Now, let's do the long way. 5 times 5 is 25. Plus 5 square root of 7 minus 5 square root of 7 minus 7. Those cancel. 25 minus 7 is 18. But darn it, it's so much easier to work with it that way. Here, when I'm multiplying the conjugate 6 minus square root of 12 and 6 plus square root of 12, 36 minus 12, which equals 24. How and why did I do that? I memorized this formula. Okay? 6 times 6 is 36. Then plus 6 radical 12 minus 6 radical 12, and negative radical 12 times square root of 12 is going to be minus 12. Those cancel. 36 minus 12 is 24. Now, last section we learned how to rationalize. If I have 5 over the square root of 6, I rationalize by multiplying the square root to both top and bottom. So I get 5 square root of 6 over 6, right? Same kind of concept here. When you have 2 radicals in the denominator, you're going to get rid of those radicals by multiplying by the conjugate. So to get rid of this denominator of square root of 10 plus square root of 2, I'm going to multiply square root of 10 minus square root of 2 to both top and bottom. So this is going to give me negative 5 square root of 10 plus 5 square root of 2 over, remember there's a difference of squares. So what's square root of 10 squared? 10. And minus, what's square root of 2 squared? 2. So this would equal negative 5 square root of 10 plus 5 square root of 2 over 8. If I want to do the long way, which I do not recommend, but if you have to, square root of 10 times square root of 10 is 10. Square root of 10 times negative square root of 2 is negative square root of 20. Square root of 2 times square root of 10 is positive square root of 20. Square root of 2 times negative square root of 2 is negative 2. Those cancel, and I'm left with 8. Do you guys see that? Last but not least, I have 10 over 5, square root of 5 minus square root of 3. I cannot have that. So I need to multiply the top and bottom by the conjugate. Conjugate. So I'm going to multiply by square root of 5 plus square root of 3 over square root of 5 plus square root of 3. Distribute. That's going to be 10 square root of 5 plus 10 square root, come on, man, plus 10 square root of 3 over, this is the difference of squares. So when I have a minus b times a plus b, it's going to be the first term a squared, what's square root of 5 squared? 5, minus the second term squared, which is 3. So this is going to be 10 square root of 5 plus 10 square root of 3 over 2. But then I can reduce that, can't I? Because 2 goes into that and to that. So this will equal 5 square root of 5 plus 5 square root of 3. God bless you all. Have a great weekend. Homework is valid. Can I add that? No, because they're not the same radicands. Thank you for asking, brothers. God bless you all.